I was getting fitted out of my mind. I always start with a title for my talk. The organizers say, you want to talk, give me a title for your talk, I have a talk title. And then as I'm making my presentation, I change it. Right? I somehow like this one, which is empowering through assistive devices. For those of you who are not aware of it, even the title Empower for the conference was something that came out of discussions that we were having during the first Empower conference, and we were hunting for titles. And we said Empower, right? And it was stuck. So the title of my talk is also Empowering through Assistive Devices. The other thing I do is first, when I come up with ideas, I grab a website. So I grabbed create.iitm.ac.in. Right? And it has a nice acronym, which is the Center for Rehabilitation Engineering and Assistive Technology. So you can, if you are from a organization, you can grab create.whatever, and then you own the IP to that. Right? Some of the work we do is around these rights of individuals for communication, education, employment, and recreation. It was very nice to see speakers talk about recreation in this conference, because in previous instances of conferences, we don't emphasize recreation as much. We always want to study books, textbooks, and I find that very boring. But being an academic, we also emphasize higher education initiatives. Last night, we had the Inclusive University Alliance, and now we are also looking at resource centers for assistive technologies in our universities. So I think these are all important initiatives that I thought I would highlight. I also work with two startups. One is the Enability Foundation, which is not for profit, and the other one is Yali Mobility. Okay. You may have heard Dr. Jacob mention this conference yesterday. It was called the Silent Revolution. The logo itself was made by the children at Vidyasagar school nearby, and it was the first alternative and augmentative communication, or AAC, conference that we had in the country. And particularly nice was this concept of a silent revolution, because sometimes I feel that maybe I've not done anything because I've not been up there making the noise about it, right? But it is silent. So the revolution has been happening. And it was based around a very specific problem. How can we help one individual, Bhavna, communicate independently? Last night I got a short lesson again, or reminder on why we started this journey. See, when we talk of solving problems for hundreds of people, thousands of people, 10,000 people, 100,000 people, 1 million people, we forget the individual. Bhavna was, I think she was still in college when I first met her. So she was in school, is it? She was still in school when we first met her, right? And it's now been, since 2005, it's now, what, 17 years? She's a young woman, right? She's gone through businesses, not one, many. Our silk saree business got flooded during the Chennai floods, right? She was on the ground floor. So you can imagine the trauma of that. But somewhere at the core of it, we remember this, right? We are building a solution for an individual. It's not for hundreds and thousands of people on PowerPoint slides. They are individuals who grow. So she was in school at that time. She's a young woman today. And we could not forget that as we go on our journey. Right? So in that sense, I think it's very important that we keep remembering the individual. The three solutions we had thought of at that time, Hope, Aditi, and Kavi, and it's interesting to see that they are still available today, right? Various levels. So the silent revolution became an evolution, right? 2005, and here you'll see, actually, I liked putting this together. I did it a few months ago for another conference. If you look at the journey, I learned about AAC in 2005, right? And then we had Kavi, Hope, and Aditi. The first startup was actually ours, Invention Labs, right? That came out of, I remember the founders at that time coming to our house and saying, what is cerebral palsy, right, on our breakfast table. INA Isaac conference in 2009, Professor Bala mentioned that in his panel discussion. And then somewhere in around 2012 were the tablets and mobiles. And in 2015, and this is important because life has moved on, but the Aditi patent, which we decided or discovered or created in 2007 was actually granted in 2015. In 2020, I think I gave it up. I said it's open source, anyone can do what they want with it, right? We started Enability Foundation there and released version 1 of Kavi Picture to Speech, which was sort of takeoff from Kavi out there. And today we have Kavi Plus and we have Kavi PTS version 3.5 and of course Yali Mobility, which is now doing its electric wheelchairs. The evolution of this is meant to tell us that hardware and software and the needs keep evolving. They're not static. As people grow, as society grows, as individuals grow, everything keeps evolving. So as startups or as people who try to create things, we have to be constantly on the move. This was the first solution that we had. It was called Kavi in 2007 and it was created with a company called Innovate Software Solutions, Bangalore. This literally was before tablets were there. So you'll be thinking, man, this guy is really old, right? But at that time, we were already looking at text-to-speech, dual audio channels and mechanical designs because everything had to be wheelchair mountable. And then 2010 was Invention Labs and then we went on to 2012 till we came to the 12 and 14 where the tablets and the mobile phones, smartphones came out, right? And the whole solution, the whole ecosystem started changing. It's interesting that in 2020, I'm back where I began. I'm saying I'm going to build the hardware. Why? Because I do not control any part of that ecosystem. Google will release a new version of Android every 6 months. And I have to sit and make everything backwardly compatible. Nothing works. The users are saying this doesn't work. You'll be amazed at how many times we send solutions to schools and they'll be using Windows XP. And they'll say it doesn't work. And I'll be like, come on, what am I supposed to do? So now I control the ecosystem. And I'm able to do that because of these single board computers. This is an example of a computer called a Raspberry Pi. It's open source, open hardware, open software. And that allows us to control the ecosystem, which is something that I believe is needed in this space, right? As an example, yesterday there was a talk by Deepashri who talked about a screening device for children with hearing loss. And this was built around this open hardware. They say imitation is the best form of flattery. So after I started building it and everything, I found that someone in China was actually doing this. Right? So, but that's okay. I also believe that I'm very happy if somebody does the work. I do not need to do all the work. We also have an application suite, right? So you'll notice games out there. We always want games to be running. And these games will work with switches. I'll show you a bit about switches, but you'll notice the kind of configurations that are allowed when we create these solutions. And trying to do this on an Android platform is really more painful and not worth the trouble. This was the first Aditi, and it was made with the help of Mindtree Foundation and Pro-Innovate Technologies, and it was priced at $15. And it's still about that price itself. We do not change the price very much. And I'll talk a bit about the price. This is the version today, which comes with ultrasound proximity sensors and Bluetooth, right? Simpler versions called the Smiley Ball, right? These are all very easy to do. And as an academic, I can always find students to set up things like this. But you'll be amazed at how much complexity goes into a simple USB thumb drive that we try to make. Right? And so you see the evolution of Kavi picture to speech. And in the process, I had to engage with designers who would draw for us, create pictures. But one of the things that we also did was we made it in multiple languages. Professor Hema is here, and her lab and her collaborators have done a lot of work in helping us make this accessible. And I think it would not have been possible without other partners who have helped us. So this is where we do the training in partnership with schools like Spaston or Satya Special School in Pondicherry. Right? Now, when we talk of these large numbers, 1 million, 10 million, 1 billion, I think we forget that this is what our schools look like. Right? It's one device. 10 children. Okay. So you divide those large numbers by 10, right? Because you're going to sell one device and it's going to get used like this, and it's going to sit inside the cupboard till the children come back the next day or the next week, right? That is the reality of our schools. I try to temper the expectations of the people in the audience. I do not know how many of you heard that talk yesterday about 31 startups being the Abhimanyus. I was cringing. You will not survive if you go into that Chakravyuh, right? No. You will survive if you understand the reality of our schools, right? You plan for this. The same software works with children with autism spectrum disorders, mental retardation, and so on. And it's been nice. I mean, look at my Bharat Jodo Yatra. I have not made it to Jammu and Kashmir, but otherwise I've done a reasonably good job. And again, I'll say all hats off to the Indic TTS. This was before Google decided that they're going to customize it. If you go and take a cab in any of our cities, they have a very anglicized Google accent telling the driver where to go. Whereas the Indic TTS will sound like us speaking, right? And it's important because the children will not use something with some foreign language out there. They want customization. They want everything to look like it. If you can't speak in a male voice for a female child, you can't talk like, I don't know, some stranger when you want to hear your mother's voice. It's fairly complicated, and a lot of it is possible because of collaborations. If I'm not mistaken, this was the first large-scale use of the Indic TTS in a product, right? And it was simply because we kept saying, no, we need to do Indian languages. We need to do it Indian languages. We need to do it ourselves. And now we have a large suite, right? So you can go on Google Play Store. You can do Kavi Plus, which is being used by educators. And you have games again. So we, again, love our games out there. And these are building a community of users. So when we release it, we release software on open platforms. We say it's a platform. You decide how you want to use it. If you wish to use it with all the teachers in your school, you can share your lesson plans. If you want to use it, share it with teachers in other schools, you can do that. And we're trying to build that community and saying, okay, let's use a Creative Commons license that allows teachers to share lessons, right? And then we also found that there were other uses for the same software. In this particular case, there were two twins called Twin Twigs. And we modified it to create a billing software that they could use to run their own businesses, right? Okay, I'm hoping that this will get played, the video. Let me just play it a bit, and I want you to watch the video. There's an audio also.
Why, Manju, what's wrong?
I need to see a doctor.
You need to see a doctor. You're not well. Okay, I'll take you to the hospital now. Yes, I can call your parents.
So that was a video that we shot maybe 5 or 6 years ago. And it was a very simple engineering problem for me to say that, okay, I'm going to build a wearable device that I'll wear. Like today, it's all very common. Again, I say, we are about 3 to 4 years ahead of the market, which is probably a good thing. These smart devices can work as assistive devices. They have an accelerometer, and we said that every time someone who was non-verbal like Manju wanted to say a sentence, so suppose she did this, to say hi, and actually the signal goes from the handheld device, the wearable device, to the phone that is sitting there, and the phone speaks. Right? So they are pre-recorded sentences, and you say hi, and you say how are you, and it's a beautiful day, and you say all the nice things. And then someone taught me the reality of their lives, right? If you could speak only 4 sentences, 4, if that is all your communication is, 4 sentences, what would they be? It's not high hovered. Okay? Given a choice of 4 sentences, her sentences were, I need to see a doctor, call my parents, I forget what the other 2 were, but they were, I need to go to the bathroom, I am hungry, right? That's it, because my software and my devices could not recognize the variety of her movements. She had very limited control movements. I'm going to drive this point home a little bit. Right? I made the engineers run this, do this yesterday at the Empower in the exhibition hall. Can we play this video also? Yes. Okay. Now, that's a volunteer, Teresa, was trying to control the car, right? Every time she raises her hand, the car goes back, and every time she lowers it, it's supposed to go forward. If she turns it right and left, it's supposed to go right and left, right? And you can see that she's struggling. This is a person with full motor skills, right? And she's struggling. Now, what are we saying? We are saying that someone who is stuck in a wheelchair with very limited motor skills can use the same device. This is a person who has all her motor skills and she has trouble using this. And it's not just Teresa, okay? I gave it to many people out there. It was a learning experience for the engineers to say, look, if you are designing something for persons with motor impairments, don't assume that they can do everything that you can. Even you can't do it. Okay, that car will crash. Now imagine if you want me to control a wheelchair with this. This is going to be very difficult, right? And it's important to understand these challenges. For some of you who may be interested, these are all the IoT devices that get used. This is a Raspberry Pi actually, and the same thing goes into a lot of our smartwatches, right? So we are repurposing a lot of these devices. The same device, the Raspberry Pi, can go into a smartwatch out here, and this was also on display. It was called Vibe for a person with hearing impairment. Very noisy environments. If somebody calls out your name, how do you know? Especially if you're hearing impaired or you're hard of hearing, the smartwatch will vibrate. It's very simple to build, we think. So we start building it, right? And then we discover that all these things are difficult to build. I won't give you a video on that. So primarily what I'm saying is that your product development has to be user-centric. We should not get carried away by the large numbers and this goal of, I don't know, impacting a billion lives. Right? The users are often at a disadvantage. They're non-verbal, they have impaired mobility, and many of them have visual impairments. And there are teams around the user's needs, right? There are schools, doctors, rehab workers, caregivers, academia, industry. But the user is centric in everything that we do, right? And people have talked about this chasm. We are the innovators. There's a huge chasm, and we can't bridge that without partners. We simply don't have the skills. The successful products get over this hump before they actually survive. So this I now put up in all my slides. It is not sufficient to have good intentions. The good intentions are as innovators sitting out here. And actually to get there is a lot of work. So to do that, we change the rules of reducing the cost. We do it by partnering with people. We allow grants to take up a lot of the costs. We use government or CSR grants. And then we train along with partnerships. Finally, the cost structure for someone like me is the bill of materials. So just as an example, if you buy a bottle of water, it will cost you about 10 rupees. The bill of materials is about 1 rupee. 90% of it is going into all kinds of things. Right? In a lot of these devices, training takes up a lot of our cost. Because if you have to go and train Manju on how to use this wearable, it's going to take a lot of iterations. Right? I think Sujata yesterday mentioned the grid model, which is you have grants, research, industry, and dissemination, right? And that's how we try to keep the cost structure down. All our products are at about 1/3 or 1/4 the actual cost of the product, right? I'll give you an example. There's Take Note. IIT Delhi is here, and I keep harassing Bala out here saying that my Take Note is 44,000 rupees. Right? It's a tenth of the cost of what they do. Why? Because I threw away the Braille cell. Right? The Braille cell was very expensive. I sync it with the phone. And if I want a Braille display, I have to find partners. The advantage is multilingual. It's all in this little microprocessor called the ESP32, and it can do grade 1 Braille, grade 2 Braille, all of that. Right? It was a product that was identified by a student in one of our design classes for one of our friends who was visually impaired. Right? The other one is a tactograph. This is testimonial to the fact that I don't have good artistic skills. I could not use fabric paint while making tactile images. So I said we'll do what engineers do and we'll build a machine, right? And it's a simple XY plotter and it uses this time-tested, patented technology called Favicol that is child-friendly, right? And you can do amazing things. You can, on simple A4 paper, you can draw mazes. We were very surprised when one of our partners decided to use this to teach their visually impaired children circuits, right? So you can do circuit diagrams, you can do Venn diagrams, all of this, right? And then the school in Pondicherry used it to teach the children with attention deficit how to color within the lines. So it was tactile and they were coloring within. So you don't always imagine everything. You don't think of, oh, this is my product, this is my success story. You just give it out there and you'll be amazed at what nice things happen, right? One more, this one's for you. You can do conversation story cards, right? Not necessarily only playing cards. So that's there, right? All right. So this is also learning for me. When I started off as an engineer, I had all these different disabilities in mind. And we were checking all these boxes and saying, hey, we are doing very well. And then I was educated and said, don't do that. Please look at functional disability, communication, education, employment, mobility, and leisure. And you'll see we are doing very poorly on mobility and leisure. Education we seem to be focusing a lot on, so that is really something that we should correct. Right? So let me end with a few pictures that came across my email recently. You know, this is apparently something that came out in 2016 and I hadn't seen it, telling us about the difference between equality and equity. Equality is where you put all the boxes equal. Equity is where everyone can actually see over the fence. And equity of what becomes a question, and then you can have different types of equity. And if you look at outcomes for every learner, there's academic, social, emotional, and other. And this is liberation, right? Where you take out the fence. So now one has to actually say what else can we put out here, which I think is an important question. So we have transferred from equality to equity, and now we are talking of liberation, and there may be something else that we are missing, and we really should start asking ourselves that question. Okay, to summarize, put a user at the center of it. Meet one need. So this is very different from everything that you've heard before. I'm coming here and saying there are a group of people who are going to solve the problem for 10 million, 100 million, 1 billion people. So please, some of you solve the problem for one person. Solve it for 2 people, solve it for 10 people. Okay, that is also important, that is perhaps more important because those people also matter. Right? Have fun doing it and keep it simple. Right? So the bell's ringing, so let me just acknowledge the Research Park, my CSR support, and the granting agencies who have supported me in this journey. Thank you very much.